make sure your note sheet says groundwater notes, and we're going to talk about groundwater. You should be able to participate in some of the notes because you already have vocabulary. Bless you. Um, when we're taking the notes, I do not want you to write these things down word for word because these are your note taking. You're going to have some note taking skills with this. So I'm going to show it, we're going to discuss it, and then you're going to write it in your own words. I will assist you the first couple times, and then you will do it on your own. So please make sure you are paying attention because I will move too fast for you to try to write down these word for word. Do you understand? Okay. So first of all, let's just go over some of the things that we already discussed. The area where groundwater is located is known as the zone of what? What is it? Zone of saturation. What are you going to write? Exactly. That's the best part of note taking because it's fast and it's quick. Groundwater equals zone of saturation. Zone of saturation equals groundwater. Quick, fast, and easy.
Do you have like air pressure?
No, I only have the air. Sorry. Open the window, Randy. Janae, open the other window. Okay. The area below ground but above the zone of saturation is known as the zone of aeration. What are you going to write? It doesn't tell you much. Above water table equals zone of aeration, or above zone of saturation equals zone of aeration. Sounds good to me. What occurs in the zone of aeration? Percolation. Very good. What is percolation? Exactly. Movement of water. So remember, if you don't remember what percolation is, in parentheses, you should probably put water movement. That happens in the zone of aeration. And you already have that there, and when you put these little stars or some type of dash, you know that that information is talking about the above stuff. What is above the ground?
Pardon the interruption. Just so everybody knows, the baseball game for this evening has been canceled. However, there will be baseball practice today after school until 5 o'clock.
Pardon the interruption. All right. What is above the groundwater and splits the zone of saturation and the zone of aeration? Water table. What are you going to write? Water table splits
In the middle.
the zones. Do you need to write zone of saturation and zone of aeration? No, because you already know that you're talking about the zones. Water table splits the zones. So that's review, correct? Those are things that we've already discussed and we've already talked about. Now, if the water table is higher than the Earth's surface, what happens? It's a lake. Lakes equal water table above
Surface.
Earth's surface or above ground. Very good. All a review, right? So now let's move on and talk about a little bit more information. Let's talk about the movement of groundwater. Make sure you title that, underline it so that we're going to another section of groundwater.
What's the underground lake? The lake that's underground.
Underground lake because you don't have land.
So they still call them lakes though. Like when you're in a cave and they go in the water and they call them underground lakes.
And I guess it would be an underground lake.
Yeah, it's a lake that's underground, man.
All right, groundwater. I'm not going to help you paraphrase this. You're going to do it on your own, but I'm going to move quickly, so you should be able to paraphrase quickly. Groundwater that flows through certain rock. What type of rock allows groundwater to flow? Permeable. And the water-filled layers means full of water are called what? The water-filled layers of rocks are called what? Aquifers. And this is where we all get our water from in North Carolina. So they're in cities and agricultural areas. No. It's how the water, remember the water goes down, it percolates, it gets down there, it goes through the aquifers, and that's where we get it from. The flow of the water stops with what type of rock? What type of rock stops the flow of water? What kind? Impermeable. Impermeable rock would be considered a what? Which does not allow water to flow. Aquitar. Again, still some more review. So if it's flowing through, then it's flowing through an aquifer. If it's not flowing and it's stopped and it's stuck, then that's an aquitard. Why would we not want to drill wells where there's aquitards? Water stagnant. Good. You can't get any water. Why would we want to drill wells where aquifers are? Why would we want to drill wells where aquifers are? So we can get water. Why can we not drill a multiplicity, lots of wells?
Water dries.
It'll dry out the water.
It'll dry out the water because what happens to the water table? The water table goes down. Very good. All right, so got that? All right. Let's talk about characteristics of groundwater.
Wet. Underground.
By its nature, it's not pure. It's not pure at all. Why do I say by its nature it's not pure? Right. But what's its nature? Where is it? Underground. Where there is what? Dirt. So it's dirty. It's not pure because it's where the dirt is. However, there is some history behind groundwater.
It'd be mud if it's where the groundwater is.
Well, it's dirty because it's where the dirt is.
Whenever dirt gets wet, it's
Right.
mud. It's a big mud.
Back in the olden days, before we had the sophistication of water cleansing, before we had the knowledge that water was dirty and we actually had to clean it, people actually thought that the soil was a natural purifier. They thought that because it goes through the dirt is going to stop all of those impurities, that once it comes through the dirt and it goes out and we get it from a lake or from the springs, that it's not dirty anymore because the dirt has already captured everything. Now we realize what? That's not true, because it's not just the dirt. What else is there? Raise your hand. What else is there?
Bacteria.
There's bacteria. There's worms, and even invisible ones like parasites. There's pollutants. Other pollutants are there. So this is not true. In today's water, it's contaminated by natural causes. Some of the natural causes will be things like radioactive material. These are things that are just in the environment because of all the sophistication that we have.
You know what Ian was here?
Brendan, stop it. It's also contaminated from toxins like animals and plants. What type of toxins from plants?
Decaying plants?
Decaying plants, very good.
Poison ivy.
Poisons from plants. What about animals?
Dead animals.
Feces,
Sweat.
urine. Because do the animals go, the dog says, oh, I gotta use the bathroom. Is there a restroom around here? Oh, I'll wait. Oh, that cat is in that bathroom. Come on, cat, let's go. I gotta go to the bathroom. No, what do? They take a squat. And they keep it going. Pop a squat. And that filters right into our ground. It infiltrates, it percolates, and it follows the same cycle per se. Microorganisms like the bacteria and the parasites, little things that we cannot see. You can get a cup of water that's impure and a cup of water that is pure, and you can look at them both, and you would probably say, this is clean water because I can't see anything. But there could be microorganisms in the water that you cannot see, which causes it to be impure. There's also pollutants in the air coming from factories and things of that nature. They're captured in the air, and when our water evaporates, it also evaporates capturing these pollutants. It condenses in the cloud, and then we get rain, and it could be polluted rain. This is how acid rain happens. And that goes into our soil, into our dirt, and it recycles it. Remember, there is no new water. Everything that you're drinking and using and washing with has already been used before. So it is very possible that the water you're drinking was in someone's toilet at one time. It's true. It's all recycled.
Under the trash on someone.
But now we have sophistication of water treatment and cleansing of water. Now we buy bottled water that has been cleaned, so they tell us.
Oh, yeah.
Jack,
Steam that comes off nuclear power plants, is that have radioactive material in it?
depends on what's going on in that nuclear power plant.
That's just the water.
All right, human pollutants, stuff that we do, like we do go to the bathroom. That's natural pollutant. We can't help to do that. We have to do it. We also wash our dishes, and when we wash our dishes, we wash them with soap. That's a pollutant to the water. We wash our body. Well, I wash my body, and I use soap. I don't. You all do not wash your bodies, which is why it stinks in here.
I love taking showers.
You wash your cars. You fertilize your grass. You do put stuff on your plants, pesticides and things of that nature. That all goes into our ground, infiltrates and percolates into our ground. And that all goes back into our water system. Those are just the things that we do like kind of naturally. Because we do things naturally like wash our bodies and go to the bathroom and stuff like that, that we can't help doing, and we add a lot of pollutants like that, what should that tell us? That we should probably not do what? Do things unnaturally or intentionally, because we already have enough with the intentional things that we do. And remember, everything's recycled, so everything that you put in your body, what goes in, must come out. And that's all going through because you cannot create or destroy matter. It just gets redistributed through the earth. Gabby's like, what? No way. All right, our drinking water, since we're on the subject.
Oh, let me put my water bottle first.
A large part of our drinking water is from groundwater. 96% of our drinking water is from groundwater, not from lakes and rivers. 75% of the United States get their water from groundwater. So again, the water that we use, the water that we pollute, all is groundwater. Majority of it is groundwater. So we have to take care of the water that we have, or we'll pollute it all, and then we won't have any clean water. That's also polluted because you have animals in there that actually, that's their bathroom. We can clean that just like we clean groundwater. But we take water from the oceans and the lakes. Remember, that's someone's home.
Yeah, man, think about the whales.
I'm gonna go take those.
All right.
Think about SpongeBob, okay?
Wells are part of the 75% of where we get our water from. Wells are man-made. You do not have to write that they're deeper than the water table. That's an obvious point. It has to be deeper than the water table if you're going to get water. But 75 of the 75% that comes from groundwater, one of those are wells. When we get our water from wells, because we all do, we get them either from reservoirs or wells within our water treatment areas, which then filters it through their water treatment, puts it through the pipe, sends it to our neighborhoods, which then sends it to our house. We have two options. One, we can get it distilled either from the store that gets it from wells as well. Which gets it from wells, and they distill it by boiling it, and then they bottle it up and then put it in the stores. Or you can boil your own water and distill it, and that removes most contaminants. Other than that, you can also use tap water. Tap water is the water that comes directly out of your faucet. It's unfiltered. It has the minimum treatment, meaning that whatever comes from the water treatment plant, that's what comes through your pipes, and that's what you get. Some of you are going to ask, what about the water that comes out of your refrigerator? That is still water from the water treatment, just like the tap water. However, it is filtered, and you have an extra filter in your refrigerator that filters it through, just like if you had a Brita or something on your sink, that would filter it through. So you're adding another treatment, not putting anything in your water, but adding something where it, like a coffee filter, where something sits there and it pulls out any other impurities that it can capture that have not already been pulled out. So you have distilled, you have tap, that's part of the well water, and then there's springs. And spring is mineral water flowing from the underground cap rock. Some people live in areas where they can capture water from springs, and of course, some of us just buy it and drink it. Yes,
So if you've been drinking tap water that's like unfiltered and stuff like all your life, do you like build up an immunity to stuff?
possible. It could be the reason why some people are sick. You know, that could be the long term or the chronic toxicity things that could be happening. Huh?
Mercury.
Yeah, you do. If you didn't want to buy the bottles, but some people have not. Some people actually make sure their water's filtered. What's the difference between a spring and a well? Obvious difference. Spring is natural. A well is man-made. We're done writing for now, but I just want to go over a couple of things. Yes.
Are the water fountains tapped?
The water. Oh yes, I should probably say that the water fountains in the school, that's tap water. The water faucets here, that's tap water. It's the same water that's in the toilet, same water that comes out of the sink. It's all the same water. I'm talking about the water in here. You don't have to write this down, but what's the problem with having too many wells? If the groundwater is removed rapidly, then what happens? Huh? So what happens? The water table lowers, and then what happens?
No well water.
No well water. We'll have dried up wells. So then we don't want to dig and form too many wells. And again, here's your spring, example of a spring, an example of a well.
No, you're not allowed to ask.
Yes. The water treatment areas actually check it out. They know. Yes.
What's the difference between a spring and a hot spring?
Hot springs hot.
Yeah, obviously. All right, that concludes